Hello and welcome to this Edexcel Further Maths Statistics 1 video, Introduction to the Central Limit Theorem. This first slide just looks at the distribution of the sample mean. And we have here this elliptical shape that is representing a population of X. And X is distributed normally with mean mu and variance sigma squared. From this large population we are going to take lots of different samples, so these smaller shapes represent samples of size n taken from my original population, and for each of these samples the sample mean is evaluated. And if we did that for every possible sample of size n, how would these sample means be distributed? And you have met this concept in topic 5.3 at A level when you looked at hypothesis testing for an unknown population mean of a normal distribution. And for an original normally distributed population with mean mu variance sigma squared, these sample means, they are all much closer together than the items in the population are, but the average of them is exactly the same as the population mean of the original population. But the variance will be much reduced, and the variance is given by the original population variance divided by n, the sample size. So I have plotted here using Wolfram, and the link is at the top of the page there, a normal distribution where the mean is 76 and the variance is 225. And what is very useful to do with Wolfram in the central limit theorem demonstration is to set it up to take and plot sample means from that original population. And so here we have the plot of sample means taken from samples of size 10 from our original population here, and evaluating the mean and the variance for these sample means. The mean is 76, the same as the original population mean, but the variance is 225 divided by 10, and you can see that the spread for our sample means is a lot less than the spread for the original population. So increasing the sample size, what sort of effect does that have? So here we have a plot of sample means where they are taken from samples of size 50, and again I've imposed the normal curve on it. You can see you still have that symmetrical shape, and you can see that the population mean is still 76. It's exactly the same as it was for the original population, but this time the variance is even smaller. It's the original population variance divided by the sample size 50. So you should already know that sample means are normally distributed when the original population is normally distributed. The interesting thing with the central limit theorem is the central limit theorem states that sample means are always normally distributed regardless of the distribution of the original population, provided that n, the sample size, is greater than or equal to 30. And it's worth pausing and taking a moment and just writing that down and thinking about how important that is. So to look at a slightly more interesting example of the central limit theorem, we have here a uniform distribution, quite easy to see that's not normal, and the population mean was 76, the variance 225, standard deviation 15. So we're clearly starting with a population that is not normally distributed. And the demonstration I set up took samples of size 40 from that original uniform distribution, and you can see the plot here, and you can notice straight away that you have that symmetrical normal shape. And also note that the mean is exactly the same as the original population mean, but the standard deviation is much reduced, and you can see the spread again of those sample means is much less than the spread of the original population. And the central limit theorem would tell us that because the sample size is greater than 30, we would expect the sample means to be normally distributed with mean the same as the original population mean, but with variance reduced by a factor of 40. And if you evaluate 225 divided by 40 and square root that, you will find that that gives you a standard deviation of 2.4. So looking at why the central limit theorem is so important, what it does is, regardless of the distribution of the original population, we may know it's differently distributed to normal, or we may know nothing about it. But we do know that if we take samples of size greater than or equal to 30, the sample means will always be normally distributed, but the sample means will have a variance reduced by a factor of n, the sample size. And it's useful for you, if you follow the link to the Wolfram demonstration, perhaps to try some very skew original populations and try some different sample sizes and just convince yourself that those sample means do end up normally distributed regardless of the original distribution. And that concludes this video. The next video will look at using the central limit theorem.